Welcome to the Refrigeration Mentor Podcast. I'm your host, Trevor Matthews. And once again, thank you so much for taking the time to listen to us. I know you're driving around, heading to another site. We're going to be diving into compressors today. You know that my background is in compressors. I work with people from all around the world, learning from so many different experts. And today we got this expert from CMP Corporation, Horace and Andy. We're going to be diving into compressor troubleshooting, understanding the things that you need to do and check out there in the field, because Horace has been doing this for decades and decades and decades, even longer than I've been doing it. And he's been taking these support calls. So when you're calling up and you're like, I need help with this compressor, he's the guy answering the calls. He's doing the teardowns. He's done tons of YouTube videos with A1. I even watched lots of them on the Carlisle teardowns that he's done over the years to get better. So I get better. And this is how I'm bringing all these experts from around the world to learn and grow, to help you as a technician out there in the field so you get better, a little bit better tomorrow than we are today. And this is what it's all about, uplifting the industry. Horace, Andy, welcome to the Refrigeration Mentor Podcast. How you doing?
Thank you, Trevor. Thanks, Trevor. We're doing good today.
Doing good.
Oh, awesome. Well, I love talking about compressors, and I know you guys do too. This is your specialty, remanufacturing compressors. And I know that decades and decades of knowledge both of you have from being in the commercial side. I know me and Horace were talking earlier, and he was like, man, my background is commercial, so hopefully we stick closer to the commercial topic. You know, and same with me. Supermarket is my background. We all know that, all of you that are listening. But Horace, I'd love you to do an introduction for yourself.
All right. Well, I grew up in downtown Atlanta, and my father had a relatively large refrigeration service company. So when I graduated from high school, I went to DeKalb Tech, graduated there doing refrigeration and air conditioning. Worked with my father's company for about 12 years, from 73 all the way up to 1985, and had a little brother that's coming behind me, 6 years behind me, that's also doing refrigeration service. And he's got my father's company to this day. But in 1985, I got purchased into the company that we were buying our compressors from there in Atlanta. And the two people that owned the company were getting up in age and ready to retire. So in 1985, I got into remanufacturing compressors. And so been remanufacturing compressors ever since. We purchased an A1 compressors out of Indianapolis, Indiana in 1998. Which give us the A1 name. We were both pretty much about the same companies here in Atlanta and in Indianapolis. And both of us were a member of the International Compressor Manufacturers Association there. And so they were having fiber optics coming into their building and wanted to buy the building. And Jay did not want to move the company. So we called David and I, which was my business partner, and sold us the company. So we bought A1 in 1998 and grew that company up to be a very large, one of the largest compressor manufacturing companies here in the United States.
Okay, so before we dive in any further, this is a question that I get asked all the time, and I work with Copeland for over 7 years. What's the difference between remanufacturing and rebuilding compressors?
It's simple. If you rebuild a compressor, if you take two compressors and set them on a bench, and one of them is a 1998 compressor, and one of them is a 2017 compressor, and you just rebuild that compressor, you just take it apart and fix what's broken in it. It might be rods that you've broken or bearings, and you replace the rods and the bearings. If you do it in both of them and you set them on a shelf, you're always going to want the 2017 compressor versus the 1998 compressor, I'm sorry. But you would always want the newer compressor. When you remanufacture, when we do total disassembly, and every compressor that you get off the shelf, when we finish it up, because of total remanufacturing there, every one of them is exactly the same. It doesn't matter whether you get this compressor off the shelf or this compressor off the shelf, they're all going to be the same. And that's kind of the difference. When you rebuild something, you just fix what's broken. And when you remanufacture the compressor, it's total disassembly, and every single one of them, when you get through, performs and has the same parts in them.
Yeah.
And has the same testing as well.
Right.
Yeah.
Yeah. I've tore down thousands of compressors now when I was doing trainings all across Canada and North America. So I'd go into events where we got a bunch of technicians and we have tons of different compressors. And there was one time I remember doing a teardown, and a technician pulled it apart and pulled out the pistons. And then all of a sudden, okay, you just put them back in, and all of a sudden the piston wouldn't go in. wouldn't go into borehole, right? So that's the difference between a rebuild and a remanufacture. They just honed it out a bit more, that hole, because that would have been an issue with that, and they just added a larger piston in there, and then that's the difference. You know what I mean? That difference versus reman and rebuild. Awesome.
Plus, total disassembly, where one of them would not be total disassembled.
Yeah, exactly. I love that. Okay, Andy, tell me a little bit about CMP Corp.
Certainly. Well, thanks again for having us today, Trevor. For those that aren't familiar with us, CMP has been around for a number of decades. We have become the largest global supplier of screw and semi-hermetic compressors. So it's been a fun growth curve. Started back in the 60s in Oklahoma City, back in the middle of the country there, with just parts distribution. And so finding HVAC parts for their customer base, and evolving and growing as they encountered supply chain issues to becoming a parts manufacturer and machine shop, even other industries that they started getting into, the oil and gas industry as well for crankshafts and other large pieces of equipment. And so we continue a lot of that today at our factories across the country here in the U.S. And our distribution locations around the world. And so it has become a nice, fun endeavor to ensure that we've got semi-hermetics on the shelf, we've got screws on the shelf, a number of products that are out there, and we're continuing to grow. We've got more coming out next year, different product types, different styles of compressors that people are getting more familiar with. And as we see the market shift, we follow that trend to ensure that we're able to take care of everyone in the coming days and the coming future. And so we enjoy what we do kind of on the backside. We're one of those companies that not many people know about, but we probably touch most of the stuff you're dealing with out there in the world. And so for us 90s kids, it's kind of like that BASF commercial that you always heard when we were growing up. That's we don't make a lot of the things you buy, but we make a lot of things you buy better. And that's kind of very similar to what CMP does today. And so that's who we are, and that's what we can bring to the marketplace and offer. So we're the kind of like the auto industry is a good comparison. We are the Napa or the AutoZone of the compressor world.
Yeah. I had a community meetup with the refrigeration mentor community, and I had a guy, I think it was Belize or Trinidad, one of my buddies, can't remember which one it was, but they were like, yeah, it's hard to get components. They got to rebuild stuff down there. It's, you can't just get a remanufactured compressor in certain places. And they're like, yeah, I get some of my stuff from CMP, some of my components. So I'm like, oh, okay, got them coming on the podcast to chat about it. So awesome. Thank you so much for that introduction. So Horace, we're going to be diving in into some technical stuff. Your background is on the technical side. Right? You've been doing this since the 80s, and maybe even before. What are some of the top like support calls you get? Because I do a lot of training as well. And, one of the things I ask, like, start to get to check, what's your superheat? And you're like, if they say it's good, we're off to a bad start already. If it's just good, like, what does good mean to you? So what are some of the technical support calls that you get when you're supporting your product?
Well, usually it's the compressor's doing something that's a little out of the ordinary. Maybe it's pulling too many amps, or maybe you have a hot head. Most of the time, a lot of times they will call up and tell me that it's keep tripping out on oil safety switch. And I ask them, well, what's your oil pressure? And they won't know what the oil pressure is. They have never even put the gauge on there to get the oil pressure. But I get oil pressure questions a lot. Oil, what type oil goes in the compressor a lot. Hot head, usually, or compressor running hot. BTUs, what BTUs, and just questions like that.
Yeah. Okay. Well, let's start on some of those. Let's talk about which one you want to take on first.
Oh, it doesn't matter.
Yeah.
BTUs has always been a thing for me. When I was doing refrigeration work, I would always kind of could tell when I followed behind an air conditioning guy, because in the air conditioning field, it's 1 horsepower per ton.
I know.
And they would always work on somebody's deer cooler. Sooner or later, they were going to get into doing some refrigeration work. And they would always put the wrong size expansion valve on. And where it's 1 horsepower per ton, when you're doing a walk-in cooler, for instance, if you have a 3 horsepower compressor, it'd be a 3-ton air conditioning compressor. But it's probably going to be a 2-ton walk-in cooler, and a 1-ton freezer on your expansion valve. So you can always follow them because they always put the wrong size expansion valve because they didn't understand that the lower the evaporator temperature, the lower the BTUs.
Exactly. And this is when you get into the performance charts and you look at the performance charts of the compressors and make sure that, yeah, as you go down, you're getting less capacity. There's less mass flow. I remember when I first started, I was like, yeah, it's I need a 3/4 horse or I need a half horse unit. And I'm just like, what does that mean? Because just like you said, air conditioned, 1 tons, 1 horse. But as you start to get down to -30, -40, that is not the case. So stick with BTUs or kilowatts, because a lot of people listen around the world in kilowatts, whatever you're sizing, that's the easiest way to do it.
Absolutely. Absolutely.
Okay, well, so let's dive into let's just jump to the next slide. So if you're listening to this onto the podcast, jump into the YouTube channel and you can go through the slides. But we'll dive into the first one, would be superheat. What does it really mean?
Superheat means that you don't have any liquid entering your compressor. Compressors, it sounds stupid, but compressors is exactly what it is. It's a compressor. It's not a pump. Pumps will pump liquid. You got water pumps, oil pumps, gas pumps, and they pump liquid. But compressors will only pump vapor. And you can put vapor in a compressor and run it at 500 psi. But if you have zero superheat, which means you have liquid entering your compressor, then you're going to find out that that liquid could be 25,000 psi. And when you do that, parts are going to break because it's a compressor and it's supposed to compress a vapor and not try to compress a liquid, which you can't do.
Yeah. And I talk with a lot of technicians in our training programs. Like I got a compressor course and I talk with them. I'm like, if you think about it visually, it's not always actual liquid that's going in there. It could be like wet gas. And I learned this from people.
Absolutely.
So it doesn't have to even be 0 degrees to start washing a little bit away, right? When you get
superheated vapor. Yes, sir.
Yeah.
And like I said, 20 degrees superheat is pretty much ideal for what most of your compressor manufacturers want to see. Unless you have a chiller that sometimes has a very, very short suction line, where you're going to have to go with expansion valve superheat, which is going to be right around 10 to 12 degrees. But any superheat is better than no superheat because if liquid enters the compressor, sooner or later you're going to be changing the compressor. It's going to do damage to the compressor, whether it be slow liquid coming in or a fast slug.
Yeah,
it's going to damage the compressor.
And that's the big thing we need to, as a technician, you're out there. It's not only that evaporator superheat and setting up you got to set up the TXV to that evaporator. So if it's a 4 degrees superheat or 6 or 10 degrees superheat Fahrenheit or 5K, you need to set the evaporator superheat. But you have to check that compressor superheat or that system superheat like we're talking about here, because if you don't know if it's wet gas, liquid going back, and this just like we said, it can start wearing away on those parts.
Absolutely, and it sounds stupid, but superheat doesn't really mean squat until the room or box or freezer comes down to temperature. In other words, you're going to have a high superheat if the room is at 80 degrees, or if the walk-in cooler is at 50 degrees, you're going to have a high superheat. But after that room or box comes down to temperature, that's when your superheat is going to be the lowest, and that's when you need to check and go back then, and then you can check your amp draw and make sure you're running the correct amp draw on it. Make sure your oil's at the right level, and then sometimes you can actually put the thing on a freezer and defrost.
Yeah, I love that there, because you don't just set superheat at 80 degrees or 75.
Exactly, and forget about it. Yeah,
you got to do it close to temperature. That's when you set it. And then I really like what you said after that. So after you do all that, you got to check it after a defrost, or when they come in and pull all the curtains down, because all these open display cases, they're starting to close them up now, but they got curtains. All of a sudden you pull the curtains down. Now all of a sudden you walk into that room and you got a white suction line, or you got a white end bell of the compressor because you didn't check the superheat at all different points.
Correct.
Yeah, I love that. And once again, when you're checking superheat, it's always the low end, because we get loads changing all the time. So your Superheat could go up to 10 degrees Fahrenheit, and then it goes all the way down to say 4 degrees Fahrenheit. Just remember, you don't average that out. Your lowest would be that 4 degrees or that 2K, just because that'll catch you. Because that happened to me. I remember one time doing an install, and I did exactly what you just said, but I didn't check it close enough to set point. I come back the next day for a follow-up, and that compressor's white. I'm like, oh my God, my heart just starts pounding. What's going on? And it's just, I didn't check it at the right time. I love that. Any other tips for technicians out there for Superheat?
I could probably think of a few. It might take me a minute, but yeah.
So sizing the valve, like you said earlier, is important. If you oversize the valve, what could happen?
Oh, absolutely. And maybe, if I could get into a little bit on the air conditioning field, where it ices back, and in the air conditioning field, of course, everybody knows if it runs short of refrigerant or ices back on the compressor there, that it floods and damages the compressor. But trying to think of where I was going with that.
Well, in low temp applications, you may see that.
Yeah. Well, too, also, I've had where they change the compressor out and the system has a small leak in it, and they'll change the compressor out, and then it'll leak down, and about a week or two or a month later, it'll flood back, ice the compressor back, flood back, tear the compressor up again. And then they just get a warranty compressor to put in there, and they just go to the system and charges it up. And then still doesn't realize he's got a small leak. And then about a month later, it tears the second compressor up. Yep. And instead of he's going to think he's got a sorry compressor, but actually what he's got is a little leak, and he just hadn't found the leak yet.
Yeah, I think that is so, so important. Like starting up any system, you need to make sure that system is sealed. You got to make sure you pull that evacuation down below 500 microns. I work with a lot of CO2 companies now. It's 200 microns. I was at a site in Georgia, and they pulled it all the way down to 17 microns. And this is an industrial system, 4-inch, 5-inch pipes going through, massive. So if they can do it on your commercial system, you can definitely pull the proper evacuation. Let's talk about that. What are the things that you would see if you don't have a properly evacuated system in a compressor?
Well, first of all, I like to say when you're evacuating a compressor, you're just trying to get the non-condensables out of it. You're really not trying to pull moisture out of it, unless you find that you have a system that's got a leak in it that you might have moisture in there. And if that's true, you better have a brand new vacuum pump and some very large hoses to pull the actual moisture out. But just remember, when you're pulling one in a vacuum, it's just absolutely trying to pull the non-condensables out of the system there. And and it does, sometimes it doesn't require maybe an hour. It depends on how large the system is, but you're just think of what you're trying to do, just removing the non-condensables. And once you do that, you can usually put it in, if it's a regular conventional system, you can pretty much charge it up right through the discharge line, or liquid line there. You can put most of your refrigerant in that way.
Yeah. Pulling a deep vac is so, so important, because if you get moisture in the system and your liquid line filter dryer doesn't pull it all out, what can happen?
Well, it'll actually, I have seen it where it copper coats everything, where it'll have an acid in there to the point to where all the copper tubing runs through there, and it'll absolutely take the valve plates and the pistons and cylinder walls and copper coat it from the acid that's left in the system as far as moisture.
Yeah. So what happens is that POE oil breaks down because they're adding moisture to
Absolutely.
it. POE oil's made of acid, organic acid, and then and water. And when you introduce water back to it, or moisture, it brings it back to that state. And so if you ever pull off a head and you see that copper on there, you didn't get all the moisture out of the system.
Correct. And I have seen the POE oil look like grease. It would have so much in it, it would actually look like grease instead of oil. Or it would be as thick as grease.
Yeah. Yeah. So for those that you don't see the slide and you're listening there, they got evidence of failures. They got loss of lubrication, liquid slugging, and electrical failures. And I like what you bring up before, when you're checking your Superheat or you're starting up your system, you got to check what your amps are, and you got to make sure that our amps are in range. What are some of the tips you give technicians when they're looking at that? We need,
your run load amps, your full load amp draw. It's always going to be when the box or room is at its highest temperature. In other words, when you start it up, you shouldn't be running full load amp draw if your room's down to temperature, your box is down to temperature. You should be way off the full load amp draw there.
Yeah, Totally agree with that. And then if you have a low temp application, a condenser, you might have a CPR in there, a pressure regulator, so you don't go over or outside that operation envelope of that low temp compressor. So checking that amps is so key, so key. I think a lot of that is missed out there. It's like, oh well, the Superheat good and the box is down to temperature. It still doesn't mean your electrical's outside its range.
You know, when I do seminars, sometimes I feel like the people are going to say, "Oh Lord, he's going to talk about superheat." But 90% of all the compressors fail because something in the system causes that compressor to fail. Yep. And if you don't find out what causes that compressor to fail, what you don't realize is everybody's time was wasted, from the guy that tore the compressor down, to the rebuilt the compressor, to the truck driver that delivered it, to you putting it in. Everybody's time was wasted if you don't take the time to find out why that compressor failed. Because like I said, 9 out of 10 compressors fail because something happens in the system, whether it be a contactor goes bad, and also the superheat. Expansion valves kind of have a lifespan on those too. Anytime you send vapor and liquid through an orifice, eventually it's going to cavitate that orifice and enlarge it. So expansion valves will need to be adjusted from time to time. Out of the 90%, I would say at least 70% of all compressors fail because liquid enters the compressor. Zero superheat, whether it be on startup or whether it be just where the coil ice is up, or it floods back in there and thins the oil out where it can't lubricate there, and you don't have an oil safety switch on it or one that's working. But 60% of them fail because 60 or 70% because liquid enters the compressor. So we've got to stop that. Accumulators are great. Suction line accumulators are just like an insurance policy for a compressor. You just have to really be careful when you're installing an accumulator, which is the tank that goes in the suction line. The only way that tells you which way it's going is it has IN usually stamped on top of your inlet on your accumulator. And then, of course, that will head toward your evaporator.
Yeah, and
we see that in the warranty reports and the teardown reports too, that the majority of the compressors, there's something wrong in the system. And it is certainly driven by the data that we all see out there in the marketplace. So.
Oh yeah, I've worked with all compressor manufacturers and the numbers are super high. Like we know over 80% is mechanical failures, and that's due to liquid coming back or overheat. And really all of it comes down to the end of the day is lubrication, right? All of those mechanical issues is all come back to lubrication because you overheat, you're breaking down the oil. You got liquid coming back, it's washing out the oil. So all these things come back to lubrication. It's just we have these terms now that we use so you can identify if it was a liquid slug or if it was a washout. So let's talk about liquid slugging. So you've looked into a lot of compressors over the years. What can cause a liquid slug in a compressor, and what are you looking for in a semi-hermetic? Let's just talk about semi-hermetics right now. What are you looking for when you have a slug?
It happens every time on startup. When the compressor comes on, if you want to slug the compressor, you're not going to slug it after it's been running for 5 or 10 minutes or longer. But when it's off and it's off cycle, then that's when your liquid's going to come back all at once. And if the power shuts off and you have 10 or 15 pounds of refrigerant hanging out in the evaporator, and it starts moving toward the compressor there, it's going to get it on startup. So liquid slugging happens on startup. And it breaks parts. Like I said, you're trying to compress a liquid when it enters that cylinder, and it can't get out the discharge holes fast enough. But it's going to break the parts. It's going to blow gaskets or break a valve reed or break a rod. And the way we can tell is because we take it apart, and the rod's just as shiny as it can be. The surface of the rods are fine. The skirts on the pistons are fine. And everything else inside the compressor is fine except for the broken parts. They're not scuffed or galled from lack of lubrication because it had oil. It just can't swallow that liquid.
And I think that's the big thing is understanding the different telltale signs, because I've opened up so many compressors, and just taking off the head will tell you probably 80% to 90% of the story. Sometimes you got to dive in deeper, and it's really hard to figure out problems on those tricky ones. But for a slug, a lot of times you can pull that head off and you can tell it took a slug. So it's either oil or liquid. Which one was it? How did it actually happen? You know what I mean? And I think diving in to tell the story, because I know for sure you could get a compressor back. You don't know the application. You don't know the refrigerant, but just by looking inside and inspecting it can tell you what actually happened to that compressor. Do you want to talk about that story a little bit when you're doing an inspection, and what's your process when you're doing a compressor inspection?
Well, we look for broken parts most of the time. If it's been slugged, it's got broken parts. That the surfaces are good for lubrication. Valve reeds mainly, blown gaskets and all. But if it's got lack of lubrication to it, we can always tell by the scuffing of the pistons and the scalding on the rods and in the bearings. We can always tell there that's lack of lubrication there. Where that would be again a slow leak, a flood back instead of a slug there on it. I will tell you this, on a slug, if it breaks the valve plate on it, that head will become the hottest head. In other words, sometimes you have a compressor that has 3 heads on it, and one of them has already been discolored from the color of it. That is the head that has the problem under it, and you can do a valve plate job. Some of your mechanics are maybe scared of doing a valve plate job or don't want to take a compressor apart. But the best thing you can do is to learn is to take that valve plate off and change the valve plate on it. Those are very changeable, a lot easier than changing a compressor.
Yeah.
But the hottest head's going to be the one giving you the problem.
And this is a tip, and I didn't know this actually when I was in the field, because I was in the field doing supermarket, changing compressors, installing, service, startup, all that stuff. But I didn't know going around and checking the temperature of each head. If it's 6-cylinder, you check the temperature of each one. If one is way hotter, just like Horace said there, that is a problem. I think in the Bitzer manual, they say 30 degrees differential. You definitely want to check that. And with the tools today they have, compared to the option I have, you got thermal imaging guns. You can just put them on your phone. They're not expensive like they were 20 years ago. And you can just go across. You can check your contactors. You can check the heads. You can check your oil temperature. It's not always perfect, but it gives you that I guess that close proximity of that temperature.
Absolutely. And also, if it breaks a valve plate, a discharge reed, or blows a valve plate gasket, the compressor sometimes will vibrate and shake like, violently there. And really, that you would think there's something wrong with the compressor that can't be fixed, but sometimes just changing the valve plate. But if you think about it, it throws the balance off of the compressor because the gas is seesawing back and forth in that valve reed where it's supposed to be. And that's what causes your heat on there. But yeah, it'll cause vibration. And if you're changing a compressor out on a rack, and I'm sure, Trevor, you probably touched on this, but it'll have a little plate in there in your discharge line that's got a bunch of little holes in it. And that's for vibration purposes also. And you'll change the compressor and you'll be lazy and you won't want to scrape those gaskets off of that little thin plate. But you need to scrape them off there real good and change that gasket, put that plate back on there, because that's exactly what that plate does, vibration.
Yeah, exactly. And I've seen it where people just didn't put it back in and didn't know what's going on in there. And so one way to test for vibration, I was taught by some gurus from Copeland, it's not super easy, but you take your pocket screwdriver, and I taught a lot of people this, and then you go across the discharge line, and all of a sudden, if it just starts bouncing all over the place, you get some pulsation. Usually you can see it anyway, but on those multiple compressor applications, sometimes it's tricky to do, because I've been at some sites where they had all the vibration gear and like 4 or 5 guys trying to figure out a vibration issue, because it can be tricky. But in those ones, like he said, if you're taking a compressor out, make sure you put that back in. There's a reason why it's in there.
Yeah, and how many of them did we ever get back with the core compressor?
Wow.
They come back to us with the core, so they didn't put them in. No longer had it any longer.
Yeah. And so just remember that you heard it here. Make sure it just looks like holes. Kind of looks like a beehive sometimes. You look at it and it has like the little holes.
You have 8 or 10 holes in it.
Yeah.
And it also, a lot of supermarkets have a heat reclaim system, and it'll also stop that refrigerant from singing, that discharge from singing through the grocery store, especially through like the stock room or whatever else. But that's another reason for that purpose of that little port. Yeah. But I always put it back in.
Yeah, that's a definitely good one. So changing valve plates is really important. Always go with the torque specs as well. This was something that I didn't know. I broke bolts putting heads back in on Friday afternoon, which is terrible, terrible with your journeyman. All of a sudden you snap a bolt. Use a torque wrench and get the proper torque specs for each one. Do it in a star rotation, just like a tire, I tell people, and that makes sense. Are you seeing lots of compressors coming back, and it could be just a valve plate replacement?
Oh, sure. Absolutely. And me and you talked earlier, but I think the whole purpose of this is so that you don't make the mistakes that I made in my 12 years of doing refrigeration service work. Because even in the remanufacturing business, we had a compressor on the roof of a facility, and it was vibrating, shaking so bad that I said, well, it's got to be a broken rod. It couldn't be the valve plate. So after we took the whole compressor down off the roof, put the new compressor in, I get back to the shop and I could have changed the valve plate in 30 minutes. It was just a valve plate, and it was shaking so bad. So, and with that, like I said, the whole purpose of this whole thing is so that you don't make the same mistakes that we made when we were doing service work.
Yeah, I know. And I agree. I've done lots of that. So let's dive in a little bit deeper. Let's talk a little bit about electrical issues and electrical failures, because I think this is where a lot of technicians would like to feel a bit more confident. Because if you take off a head and you see a broken piston, or if you pull it off and it's all burnt, and the compressor is just a full winding burn, you kind of get a good idea. But on the electrical side, I think there's some things using your meters that a lot of technicians don't know enough of. I think they know how to do the winding resistance quite easily, matching it up, like shutting it off safely, locking out your power. So there's and then double checking with your meter so that you've got no voltage before you touch those wires and taking them off, and they can go and do the resistance. But let's talk a little bit about electrical troubleshooting and compressors, what you see and what you hope more technicians could probably jump on to look for before deeming a compressor failed.
Well, contactors have a lifespan. And if you don't know when that contactor's been changed, especially if you're changing a compressor, go ahead and, the compressor is the most expensive part of the system. And the contactor is one of the cheapest parts of the system, expense-wise. So go ahead and change the contactor while you're changing the compressor, especially if you don't know how long it's been on. But also, even if you don't, take the cover off and inspect the points and see how they look. If they're really pitted, for goodness sakes, go ahead and change the contactor there. Always make your electrical connections metal to metal on your. A lot of times, Carrier has insulators, especially on their 06E compressors, and we have a lot out in the field where they just put their lead wire down on top of the insulator and then just put a nut on top of it. Well, then that post eventually gets hot because you can't get it tight enough to do what to make a good connection there when you're going to pull something at 40 and 50 amps on one leg. So sooner or later, it'll heat that post up and then the terminal starts leaking. Always make your electrical connections metal to metal. You want like a nut on the bottom, and then you want your wire, and then you want a nut on top to make sure it's all metal to metal on your electrical connections. I tell you also, though, when you come up on a compressor and it's all burnt, it really doesn't mean that you have an electrical problem. You still could have a mechanical problem because, and what we haven't touched on is if you have a slug and your suction reeds are busted all to pieces and your piston looks like sandpaper, it looks like it's been bead blasted, then change the compressor, because all those little pieces on the suction reed now, not the discharge, because it goes right out the discharge, but on your suction reed, if they get in and get on top of the electric motor, and it might be a day, it might be a week, it might be a month, but sooner or later, it's going to burn the compressor up. So every time you have a burnt compressor, just don't think, okay, I have an electrical problem. You may have a mechanical problem also, and that's what caused the compressor to burn. We really hadn't touched on part wind start. And if you guys do commercial refrigeration or air conditioning long enough, you'll be where part wind start. You can run up on something that has two contactors that brings the compressor on. And if you're changing out that compressor, you need to mark your terminals or in your contactors. If you change them, mark every wire exactly and put every wire back on exactly. Because when it has one contactor that runs half of the motor and the other contactor runs the other half of the motor, and they'll either bring them in together or they'll bring them in a split second behind one another. But if you just cross one wire, you have half the motor trying to turn clockwise and the other half the motor is trying to turn counterclockwise. So it just hums and locks up, and it doesn't take but maybe 15 or 20 seconds to burn the compressor right up because you're pulling lock rotor amps on the little motor wires. There. So always, and that's part wind start. And eventually, if you do it long enough, you will come up on those systems that are part wind start.
Yeah, as well as dual voltage motors, the 230 and 460. Like you gotta check how you're wiring that up, because that's so important. If you wire it up for a 230 volt motor, and then you put in a 460 motor, you wire it up to 230 and you hit it with 460, that compressor is in trouble. So
Yes, sir.
just diving in, and at the back of like every compressor electrical plate will be the wiring diagram on the back of there usually, so it'll show you. But take a picture. Most of us have phones today. Take a picture, just like we were talking about, and mark out those wires so you know, because sometimes you have to pull off that electrical box to get that compressor back in, but you need to know those terminals that you need to put it on. So important. I love that.
And while we're talking on electrical problems, and we've been talking about semi-hermetic compressors, but if you have a scroll compressor that's 3-phase, and I did it on my church, 3 months ago, but if you run a compressor, a scroll compressor backwards, it's going to sound like it's going to. If you get one thing, if you run it backwards, it's just going to sound like it's going to blow up.
Yeah, it sounds like marbles.
Absolutely. And there's nothing wrong with a compressor. You just got it running backwards. So the scroll compressors, if they run backwards on 3-phase, it lets you know it. And I could not turn it off fast enough. And I knew what I was doing, I thought, but I just crisscrossed one wire or 2 wires there and caused it. So, like I said, this whole video or this whole podcast is to help you be a better mechanic.
Yeah, for sure. So this is why when you do any startup, you have to have your gauges on. Like there's no ifs, ands, or buts. You need to have your electrical meter there. You don't just turn the switch on and hope that it's going to run totally fine. You got to have your electrical meter there. You got to have your gauge on, because if you turn that switch on and all of a sudden your discharge is not going up and your suction's not going down and they're staying even, you're probably going to rewire it, right? Just switch one of those legs.
And eventually you'll be on screw compressors, and screw compressors have got to go one direction, or they will certainly wash themselves out, because a lot of them don't even have oil pumps. Some of them don't have oil pumps. They're all pressure fed oil. So you want to make sure it's going in the right direction. Yeah.
I think a big thing is I've seen a lot of for electrical one where people will go and they'll go across the winding, and then it'll be like, oh, it's a shorted compressor. But actually, like you talked about earlier, it could be that contactor that is shorted, not the compressor. So this is why you always got to check it. If you get weird readings, because I've done it, you check it from the contactor first, and then, it's perfect. You're always going to have a little bit more resistance than what the manufacturer says in their thing, a little bit more, because you get that wire you're going through, because there's a resistance in the wire. But if you get weird readings, you got to go directly to that compressor. And then even when you go directly to compressors, those insulators could be failed as well. Yes. I'm sure you've seen this before. Pull the insulators off and then check it. And then that's how you verify 100% if it's the compressor, or maybe it's that insulator that you were talking about, like on those carriers.
Insulators, or they have carbon in them, and I always put the new insulators that come with a compressor on. Don't use insulator. Always use new one, because they, like I said, they'll short out and run a lightning trail almost. When you turn it on, it'll sound like an explosion. So I don't want that to happen.
And also, if you see the terminal lugs and they're all rusted and they're damaged, change cut the wire, put new lugs on there. It comes in the kits. Put them on there, because I've seen time and time again where a compressor failed because they just used the old wiring. That was the issue the whole time. It was loose and you could not tighten that lug.
Correct.
Awesome. Okay, what are some of the calls for overheat? We talked about it already. You got a busset suction. You could have a really hot head on it. What are some of the things that cause compressors to overheat?
Dirty condensers mainly. You have a dirty condenser, it's going to overheat there, and just broken parts. Also your relief valves in there are set to pop off about 350 degrees. So, but yeah, overheating is a big problem. But maintenance, everything that we talked about, a good preventive maintenance system will help you. And make your own. There's 2 things you need to make. Maybe make up your own startup sheet when you have a compressor failure. It'll make you check things that you normally would forget or you wouldn't check there. So
okay, this is good. Okay, so how can we help people? What should be on this compressor startup sheet? So I'm sure you guys have tons of them that you send out to all your customers. But if I'm a technician and I'm gonna go out there and I'm gonna build my own. I'm out there. They're listening right now. I'm going to a site right now. What should be on that compressor checklist?
Full load amp draw. Make sure you check the full load amp draw of it. Make sure you pull it into a vacuum. Like I said, take a picture of the wiring on it.
So let's go back to that. You just said pull it into a vacuum. So we're talking about semi-hermetics here. What does that do?
Oh, it gets out all the non-condensables like we talked about.
Also doing it on a startup, doing an evacuation, pulling it out, I'll get the vac pump on it. I get you. I thought, okay.
Yeah. And if your compressor is not burnt on a semi-hermetic compressor, close your suction and discharge valves, front seat, both of those. And then, when you change the compressor, all you got to do is pull a vacuum on the compressor itself.
Yeah.
Yeah. And not really lose any gas. I have so many people talk about, well, I have to remove all the refrigerant out of the system. Well, why? Just close your suction discharge if they're holding, and on your oil return there on the rack system, you'll have an oil return. And so close those valves and just change the compressor out. You don't lose it. You really don't lose it much refrigerant.
Yeah, most of racks always have service valves. Sometimes on a condensing unit, I've seen where they just pipe it right in. Not very fun. But okay, so you make sure you evacuate it if you're doing a startup, or even if you're installing, you just installed one. You got to pull the non-condenser out of that compressor. What else should be on the checklist?
Check your contactor, change the contactor. Again, like we talked about contactors, change the dryer. It's very inexpensive there. Change the dryer on it. And Trevor, I don't know how you feel about it, but sometimes they get in trouble putting a suction line filter on, and that's good after a burn, but just remember, suction line filter is just trying to get the acid out. And they do make products like Acid Away that will, remove the acid out of it. And I've never really known of a compressor failure that was caused by too much Acid Away or additives in the oil like that. But and that's a personal opinion, whether you want to use Acid Away or a suction line filter. But if you decide to put a suction line filter on it, try to mount it vertically and not horizontally so it doesn't trap any oil. Sometimes it doesn't take but a coffee cup full of oil to damage the compressor on a startup.
Yeah. I don't recommend myself. I never use Acid Away. I always put a suction line filter dryer and then removed it if the pressure differential gets over what the manufacturers recommend. Because they say it right in there. You go into Sporlan, you'll go into the Copal ones, and they'll say, like, depending if it's a permanent installation or just a temporary installation, they'll tell you the times on when to pull it out after 24, 48, 72 hours. But this is something that you need to check. And I did a chiller training. I do chiller trainings as well. I had a technician out of California on the chiller. They never do that check. You know what I mean? Like, because the chiller's small, they never check both sides of the filter dryer. You know what I mean? And he said that he was telling me this. He was doing the two units always ran because they had a backup unit and a regular unit. They always ran for like the last 2 years, he said. And he was in the course, and it's like, you got to check the pressure differential across there. And he went and checked it, and it was a 60 psi pressure drop on one unit. So that's why the two units were running the whole time. And he just didn't know. And said, well, how would you if no one ever taught you? And he said he changed that. All of a sudden, only one chiller was running.
Yeah.
So it's good. You got to check that stuff.
Yeah, pressure drop, like you talked about, though, it'll also make the compressor run hot too because you're running a lower suction, like not getting enough gas across it to help cool your windings or cool your compressor. And so there
mass flow. You're not getting that mass flow, that cool gas. These are refrigerant cool compressors. That cool gas over. So get back. So you use Acid Away quite a bit, and you never seen any issues in some of those compressors that came back that
Correct.
had in it?
Correct. And Carrier used to make a little system, where you could do both, where you could check the acid in the system there on there.
Well, there's lots out there. So I work with a lot of people on the large commercial stuff, industrial stuff, and you got to send this out to the lab. Like, you can go to Sporlan and other manufacturers you go to United, Johnstone, RSL, Master, whoever, and you can buy like a little acid test kit for the oil. You won't do this on little tiny 1 horsepower or one units or 5 ton, but on a rack system where you got dozens of liters or gallons of oil, you're going to want to check that. But I always recommend a lab analysis when you're doing that much. Not just little $100 kits. You go send it out to a lab and check it. Have you ever done that, recommended that for your customers and checked do a lab analysis? And what are you looking for in that oil?
Yeah, we have done in the past many years ago oil analysis and send it out. I never have really recommended it to the customer because he just ain't going to do it anyway. But we have sent oil analysis off. Just and you're looking for carbon in the oil, maybe a little depending on how you seal it, moisture content into the oil. A lot of times they'll turn yellow. On a clear oil, a lot of times they'll turn yellow. But the metal particles, aluminum, brass. You're looking for stuff like that in the oil.
Yeah, and that's so important. That's the difference between just going from an acid test kit where you say, oh, we got a little bit of acid, or not looking at a color sheet versus you getting numbers. Here's the parts per million. This is how much iron's in your oil. This is how much phosphorus is in your oil.
Right.
You know what I mean? This is the all the different gases, that non-condensable that potentially is in that system. So this is why super important, especially on larger systems, to send it out to a lab. Awesome. So what are a few more things that you could put on that checklist for them when they're building the checklist? So pressures, temperatures, I would say. So suction
cleaning the evaporator and the condenser, cleaning those. Making sure if it's on a walk-in freezer or any kind of little freezer there, make sure that your evaporator fans are not running all the time. Most of the time they're set on what they call a defrost termination switch. If your evaporator fans on a freezer are running all the time, then when you start that freezer up, then you're making the compressor act like an air conditioning compressor. It's going to overamp. It will be over its full load amp draw there. So if your evaporator fans are running all the time, they probably on a freezer, they're probably not supposed to be that way, and somebody's probably jumped that defrost termination switch out. Also, that defrost termination switch does not allow it to go on defrost with the boxes a certain temperature. So I have seen it where they would jump that out and it would absolutely melt the door gaskets right off the glass doors because it goes into defrost when the box is 80 or 90 degrees.
Yeah, that's a great tip. I learned that when I was doing installs, and I'm like, why do I got this door switch on? And I open the door and all of a sudden I hear a click, and that means the solenoid's closing. So you're pumping down that circuit and the fans go off. You know what I mean? That is important, because if you haven't worked on a lot of these systems, you're bringing a lot of heat in there, just like we're talking about, and that's going to overload that compressor. So good. That's a great tip.
And how many walk-in freezers did you go into and see the fan guard all snowed up and the fan blade going ching, 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 from hitting ice? And that's because they want that coil to get below 32 degrees to freeze that water, the moisture and all there. After defrost, you want it to freeze and stay on the coil and not blow onto the fan blades.
Or the roof. You walk in. I walked into so many, and there's frozen droplets all over the roof. That's something going on with your defrost or your fan termination. You got to have a drip time after the defrost. So you go into the E2 or the Danfoss or microthermal, and you set up your drip time. Follow manufacturer's instructions. It's all in there. It could be 5 minutes. It could be 10. It all depends. But you gotta look at that stuff. And these are just visual signs. This is before you even need tools out. You can go and take a look at that, and you say, "Oh man." And we got something going on here. Let's check this evaporator coil, and then that affects what's going back to that compressor. Okay, great.
And one thing, Trevor, we will gladly share with your audience the link to the startup guide that we provide, and then they can build their own template from there and have something that they can use for the future that is more specific to them.
Yeah, and it's important to do this. And I always, like in all my compressor courses and all my training courses, I get them to go do that stuff. So if you come into course, I want you to go out and actually apply that stuff, because what we really do, everything's on facts. Refrigeration's facts. There's no real hypotheticals. You get the numbers, and this is what's happening. You get the pressures, you get the temperatures, you check the coils, it's visual, you're touching stuff, you're listening to stuff, you're getting your volts, your amps. It's all about facts. When you have all those numbers, even if you're not really that great at figuring out what's going on, if you give it to an expert and they see these numbers and they're the right numbers, they can usually tell you what is going on with that system. They can give you, you got liquid in that compressor, or you're running your evaporator too high, or your condenser's not rejecting enough heat. So you know what I mean? Just by looking at the numbers, the more numbers, the better.
Everything's about data. Yeah.
And if you have a failed compressor there, you go ahead and take the heads off of it. If you take the heads and valve plate off of it, you can learn from stuff like that. You can learn about the compressor, and you learn how to change a valve plate. It's not hard to change a valve plate. Sometimes scraping the gaskets are a little hard, but other than that, that's pretty much a simple thing to do. It's a lot easier than changing the compressor out.
Yeah, especially.
while I'm talking about valve plates too, I always hit in my seminars is that if you buy a Copeland valve plate kit, a Copeland compressor valve plate kit, whether it comes from CMP or whatever, you're going to get several what we call valve plate gaskets, and you're going to wonder, and they're all going to look the same. To the layman, they're all going to look the same. But the one that you want is the one that matches the cylinder wall exactly.
100%.
They're going to be the difference in those gaskets is the bore size of them. So if you put one that's hanging over inside the cylinder and you leave it there, it's going to knock when you turn the compressor on. If you pick one up that's hanging outside the cylinder wall, which is too big for the actual piston, then you're going to have all this high compression gas there, and you just kill the efficiency of the compressor there. So you always want to match that gasket up. You're going to wonder, why do I have all these gaskets that look just alike? But you want to match the cylinder wall.
Yeah, exactly. That's a good one. And one of their guides is good. It's the 40/60 parallel rack one, and it explains all that, like the bore size, why they put that in there, the thickness. There's, we could dive. I could spend an hour talking about why is there one that's a 0.3 mil versus 0.6. It's all about the efficiency and the different compressors because there's just so many. So I'm glad that you brought that up. Yeah, this has been good. What are some final thoughts that you would like any technician? Because I know you get a lot of calls from technicians out there in the field, and they're looking for some support. But what are one or two tips you'd like to give them to help them out in the field so that they're better tomorrow than they are today?
Well, I guess I haven't touched on this, but one thing: never, ever, ever put 410A in a semi-hermetic compressor. Most of them are not built. There's only just a few that's ever been built that would run 410A, but never put 410A in any of our compressors that we remanufacture here at CMP.
I've never heard of anyone put 410 in it. So people,
I got it in my truck. Now, what I'm saying is, okay, I'm a little short of refrigerant, and all I got in my truck's 410A, and it takes 404 or whatever else. But it's and also the relief valves in these compressors are going to pop off about 350 or 375 on the head pressure. And so they're just not designed to run 410A. So that's one of my sticking points that I always try to put in there. Other than things, it's like I said earlier, find out what causes the compressor to fail, or you're just wasting your time, there.
Oh, for sure. Because like I said, I've tore down thousands of compressors, and you look at the model number of it and the serial number, and you can be like, this has been replaced already. How many times has it been replaced? This is the third time it's been replaced. Why does the compressor be replaced 3 times? You know what I mean? Check that oil level. What is the oil level? Was there oil in the compressor? What color is the oil? Why? You know what I mean? Like, these are things that you need to be thinking about. And a lot of this is visual and touch. Like, a lot of this I know for sure. You can check it by just discharge is always going to be hot. So you be careful when you touch the discharge. But if you touch it and it burns your fingers right off, it's probably running too hot. It's probably running too hot.
One of the things too that I try to if you come up on a system or if you're charging a system and the condenser's clean and your liquid line starts going from warm to hot, then stop putting gas in it, because you're removing all the BTUs that the compressor and the condenser are designed to remove. So any gas that you put in there with a hot, other than maybe summertime, but normally if your liquid line starts going over from warm to hot, you need to stop and charging gas, because you're removing all the BTUs for one, and the other you're probably just filling up the receiver tank. So, but
you don't need that much.
That's one of my 5. That's one of the 5 ways I talk about charging the system up. The other one would be the gut feeling. In other words, when you're charging the system up and you close your suction, your valve on your gauges on your suction valve, and your suction pressure is either maybe 10 pounds lower than you wanted it to be or thought it would be, or maybe 10 pounds higher than it should be, then that's your gut telling you there's something wrong with the system. So maybe you don't want to leave it there. Maybe you want to check a little further into why am I running a lower or a higher suction than I really should have. And that's what I call your gut feeling.
Yeah. Oh, for sure. Go with your gut. It does take time. You don't learn this stuff overnight. You got to get it. We're talking about this right now. You're driving around in your truck or you're watching the YouTube video, but you got to get out there and put your gauges on there. You got to put the tools in there. You got to work on more equipment, get your electrical meter out there. You have to be safe, first of all. So understand, have your PPE on. This is so important so you can go home to your family at night. But the more you work on the compressors, the more that you get to see the more you listen to them, because I know technicians that can walk right into a rack room and it's normal person walks in, oh my God, this is loud. They walk in, it's like that compressor 3 is knocking. There's something wrong with compressor 3 or compressor 4. And most people are like, I don't know, I don't hear anything. It just sounds like a loud motor. So you'll get that over time as you work more on these systems. I wanna thank you guys for taking the time to come and chat with me a little bit about compressors. I do appreciate it. How can people find out more about you, more about your organization, more about your trainings?
Certainly. Well, we have a wonderful website that's about to be relaunched as well in July, coming up on a new site with all kinds of new educational information, new self-service, and new access to product information as well, with a number of specifications that have not been out in the public in the past. And so that will be cmpcorp.com is going to be the website's domain, and it's going to be pretty cool. We'll get ready to launch that in, I think, 2 weeks. Is that right? Yep, 2 weeks. And if you guys want kind of a preview for that, you're welcome to go hop on there and get signed up for our email newsletter. And we send out technical tips and tricks and things like that all year long for folks to be able to learn and grow with us. And that's what we really encourage, and we really appreciate the customers that do read our warranty reports and actually call us and try to get more additional education and information on how to improve and how to get better. And so we are glad to provide that along with our YouTube trainings and all of the information that we have out there in the World Wide Web for everybody to get involved in. So it's a plethora of information.
And Trevor, I'd like to say too, for you guys out there that have helpers, let your helper be hands-on. Help your helper to be hands-on to make him better. And you helpers out there, if you know you're the guy that you're working for or with there is going to need the screwdriver in just a minute, have it ready for him. If he's going to need the pliers, have it ready for him. Be the best helper you can be. And you guys out there, let your helpers be hand-on. The reason I say that is because, like I said, I had a little brother 6 years coming behind me that in there, and I would have him fixed and done before and never let him do anything. Of course, he did go to school to take it, but when my thing was put them in and get gone. And so I want y'all not to do that. I want you to check your systems out, because like I said, I put them in, turn them on, and get gone was what I did when I was 20 years old. Don't do that.
Yeah.
Thanks, Trevor.
No, and I like that. I think it's so important to help train the other people, and it does take longer. As a lead, I know as a lead technician, you just want to get this job done, get the next job, and go home. Mm-hmm. But that's not how the other people learn sometimes. And I've been working with people all over North America, all over the world, teaching lead technicians how to work with the apprentices and how the apprentice needs to work with a journeyman. Just like you said, be the best. If you're that's how I got so good at stuff. When I was doing construction, if I was pushing cases, I wanted to be the best person pushing cases. If I was laying cases out, I wanted to lay them out the best and easy, getting the level out, getting it properly. If I was doing drains, I wanted to be the best drain guy, whatever it was, piping, compressor, service. Just try to be the best at whatever you're doing, and you'll see yourself start to advance a lot faster than everybody else, because everybody else is just doing what they're told to do or just going as status quo. But those of you that put that hard work in now, it always pays off later. It always pays off later.
And learn how to seal floss.
Yeah, that's it.
Learn how to weld pipes together. Yeah.
I totally agree with that. I want to thank you guys so much for taking the time. And those are for you listening. Go out and check them out. Go get their service guides as well, their checklist guides to help you. The more you read from all the different manufacturers, that's how you get better. I read all the manufacturers. I'm learning from all the different people, because you can learn 1 or 2 tips that's going to really help you out be better as a technician. As always, thank you so much for taking the time to listen to this. Head to the refrigerationmentor.com website. Check out the different things that we have going on there all the time. As you know, we got lots of stuff. And if you enjoyed this, share this on Instagram, share this on LinkedIn, leave a review and tell us how we did. How do we make this better for you as a technician if you want to grow and learn more? Once again, I want to thank you guys so much for taking the time. And as always, let's get a conversation going. Thank you.